Hi all. Today we are going to see about basic routing protocols. That is nothing but a RIP. Let's get into the video. First of all, what is a RIP? RIP is a routing information protocol. It's work on the basis of distance vector routing protocol algorithm. It works on the algorithm is distance vector routing algorithm. It uses a metric called as hop count. First of all, just have an idea about what is a metric. If you ask me what is a metric, metric is nothing but to reach a particular destination, which is the best path to reach it. So that's what is called as a metric. Suppose if you are traveling from a place A to a place B, there are many ways to reach it. But according to us, which is the best way to reach? Some will think of going via car, some will think of going via bike, and some by walk, or some by train, or some by bus. Whichever be the means of transport, they will think by according to their wish. I am going via bike. This might be the best path to reach the destination. I can reach in so and so time. I am going via car. I can't able to go in such a small road. This is my best path to reach. So they may think of it. So which is the best path to reach a particular destination is said to be as a metric. It differs on each routing protocol. In case of RIP, it uses a hop count to reach a particular destination. The metric is used here in RIP is hop count. That's it. And what is the maximum number of metrics? That is a hop count that is being used in RIP is 15. Suppose if you are having a hop count of 16 in RIP, it is being considered to be as infinite. That is, it is unreachable. Maximum of 15 only it can handle in terms of RIP routing protocol. Then we move on to AD. The AD value is 120. What is an AD is? It is an administrative distance. It is some sort of trustworthiness to the routing protocol. Lower the AD value is best in order to reach the if you are having two routing protocols, RIP and OSPF or RIP and UGP, whatever be the routing protocol. If you are having a particular network, the same network, to reach a particular destination, the router chooses. Router is now as a typebreaker. It chooses the AD value to reach a particular destination. The router chooses the routing protocol with the lowest AD value. Let's consider to be more clear. Consider one routing bank router A. It has to reach a router B. So consider the segment of 192.168.1.0/24. RIP and the OSPF both using a routing protocol of 192, both using a network segment 192.168.1.0/24. Suppose both have same value, everything seems to be same. Now the router has to decide which routing protocol or which interface it has to exit. So it chooses the AD value of a routing protocol at this time. It checks the AD value. Since the RIP has the AD value of 120 and considered to be as a OSPF having AD value of 110. It chooses the OSPF and then it chooses the path. Lower the AD value is better. It might be a tiebreaker at some critical situations. If you look at nowadays, the RIP is outdated protocol since it has a very limited hop count and some drawbacks in that. So we are using alternate protocol as OSPF or UGP. Now the newly implemented sites will not use a RIP. Only old existing sites may have a RIP. So that's it about a RIP introduction. Next, there are two versions of RIP. They are version 1 and version 2. What about the version 1 and version 2? We will look into it separately. What is the RIP version 1 in the sense? It will not support a classical routing protocol. Consider an IP of a class A segment as 10.1.1.1. If you are assigning an IP address of 10.1.1.1/24 in your network, that is in your IP address, then if you are advertising this segment 10.1.1.1 in your RIP, it will not consider as a 10.1.1.1/24. It will consider as /8. That is only the 10 segment 10.1.1.1/8. It will be normally as 10.0.0.0. Since it will not support a classless, only that it will looks into the IP address segment to which class it belongs. whether it belongs to class A or class B or class C. According to that, it chooses the default subnet mask of that class. That's what a RIP version 1 does. Then it will not support any authentication. There is no authentication we can configure for in terms of version 1. Then manual summarization also cannot be enabled. That is the same as classful routing protocol. Manual summarization cannot be enabled. And one more thing, it sends only the broadcast packet to the neighbors to form a RIP package exchange. It just sends a broadcast packet. It will not support multicast or any unicast packet. And version 1 can send version 1 and receive both versions, that is version 1 and version 2. It sends a version 1 and receives both the versions, maybe a version 1 or version 2 in the sense for version 1. While in case of, let's come back to version 2. Version 2 is a classless routing protocol. Manual summarization can be enabled. That is, if you want to use a particular network, that is a /24.192.16.0.0 segment is been given a slash of 24. By default, it chooses /16. But if you give a manual summarization, that is, if you are disabling auto summary, then automatically the network that has a particular subnet mask in the interface will get into the routing protocol over here. Then it uses a multicast, while the version 1 uses a broadcast to send packets, while version 2, which uses multicast. That is, the multicast IP over here is 224.0.0.9. It also supports authentication, both MD5 and plain text authentication. But in case of version 2, it only sends and receives version 2. It will not support a version 1. If a packet is coming from a router that is configured with a RIP version 1, it will not support it, and the RIP adjacency will not be formed between the two routers. So we make sure while configuring a RIP, both the routers has to be in the same version is better for exchanging of routes and packets. Next, we move on to the configuration part. Let's consider these two routers. Consider as router 0. Just make a note of it's router 0 and this is router 1. And it's been connected via serial interface 0/0. 192.168.12.0/24 is a segment. And we just do the configuration how to do it. And one more thing, I just have created a loopback in router 0. Loopback in router 0 as 1.1.1.1. Let's get into it. Okay. Go to the router configuration mode. First, you need to go to the configure mode and then enter into the router configuration. That is the routing protocol configuration. We just want to enter a router RIP. Then we will enter into this command, a config router. That is, routing protocol is going to be configured. That's what it means. Then just make a note of is no auto summary. This means we are enabling a manual summarization or disabling your auto summary, so that the default subnet mask of a particular class will be disabled and the concerned subnet mask of the network will be enabled. In the sense, if you want to enable a 10.1.1.1/24, if you haven't entered no auto summary, it will be considered as 10.0.0.0/8. And when you given a no auto summary, it will be considered to be as 10.1.1.1/24. So that's the use of a no auto summary. And we need to enable a version 2. If we haven't enabled a version 2, the no auto summary will not be enabled. Since version 1 is default and version 1 will not support no auto summary. That is, it will not support a classless routing protocol. And coming back over here is network 192.168.12.0 and 1.1. These are the IP address that I have configured in the router. That is, this interface 192.168.12.0 12.1 over here, it's 12.0 network segment. This and internal loopback IP address 1.1.1.1 that I am just advertising it over here. And the same configuration is to be done on the router 1, router 0 and router 1 we are using here, and same configuration is to be done on the router 1. You can just look at it, no auto summary, version 2 and 12.0, that is the network that we are advertising. And if you want to check our configuration, show IP protocols. If you just give a show IP protocol, it will give you information about which protocol you are using. RIP. Over here is show IP protocols will give information about a RIP and the default version. By default, it uses a version 1. Since we have enabled a version 2, it has been showing here as version 2. And version 2 is the only version that can receive and send only version 2 packets. If you have configured other router as version 1, they will not form adjacencies. And which interface you can check it over here is serial interface. Version 2 can send and receive version 2, and there is no authentication that is being configured. Authentication, you need to create a keychain and you just want to do the process. And automatic network summarization is not in effect. That is, we have disabled the auto summarization by using a command no auto summary. And the routing protocol over here is 192.168.12.0. Since it is a router 1, we are having only one interface IP, that is serial interface IP. So it is showing as routing for networks. This network is being advertised. And the default distance, that is the AD value, is 120. Now we can look into the router 0. Just make a note of it here. And we have also advertised a loopback. For version 2, there is a loopback 0. And the IP over here is 1.0.0.0. From this router end, it will see only the classical routing end. That is 1.0.0. segment only be advertised. While in case of a other end router, that is this is a router 0. While in case of router 1, we can check whether it is been auto summarized or whether it is given a consent subnet mask of the consent router. We can just get a look into on the router 1. Yeah, it's a RIP verification. It's a router 1. We are just verifying on router 1. Since we have an IP address on router 0, we just want to confirm it on router 1 that the routing protocols enabled interfaces other than the connected interface has been given to via routing protocol, has been learning via routing protocols. To be more simpler, whether the RIP routing protocol advertises 1.1.1.1 routing protocol network. That's it. Show IP route RIP is a command to check only the RIP. If you are giving a show IP route, it will show you all the connected RIP, OSPF, EHP, what are all the interfaces that are learning in the routing table will be shown. That is using a show IP route. I just want to know about a RIP, so I'm just giving about show IP route RIP. Then you can just make a note of here 1.0.0.0 is being divided as /32 subnet, and the IP over here is 1.1.1.1. It's learned via routing protocol RIP with the AD value of 120 and the hop count is 1. That is, this is one router ahead. The next router and its loopback. So that's why consider it as a one router ahead. And it's been via 192.168.12.0 a serial interface 0/0. This is the next hop IP 12.1 and this is a serial interface 0/0. To be more simpler of how it works, just consider this network. I have also created one loopback 1.1.1.1 and I have advertised these two interfaces, that is a loopback interface and serial interface in RIP, and I have configured a version 2 and disabled auto summary in router 0. And while in case of router 1, I just advertised this interface, that is a serial interface 192.168.12.0 segment and its version 2 and disabling a auto summary. What does it do? It just matches the version 2, both the end versions, both the version 2, they exchange the information. They exchange the information from router 0 to router 1 and from router 1 to router 0. And then since it is a directly connected, 12.0 is directly connected, it will not comes under RIP routing RIP route, that is a routing table of RIP. Since as it sees about the directly connected interfaces has an AD value of 0, since it gives a more priority based on the AD, router gives a more priority to the directly connected interfaces since it has a AD value of 0. So automatically the directly connected interfaces will not be advertised via RIP. Only the other interfaces, other networks other than that directly connected will get advertised into the RIP. In this case, I can check it as 192.168.12.0/24 over here. This has this segment. So automatically it will check this segment. This segment, both are in the same segment. So automatically what happens is that the router thinks I already have this interface in my router. So it is directly connected. So this interface, this both end will be in the directly connected form. And then it will check about other networks. So 1.1.1.1 will also be come into this router and just thinks about it from where I have learned. It just thinks about it and make a note of it. It learns via routing protocol RIP. So RIP and its AD value, all the information will be set into the routing table. And this is how it learns about the networks. This is how the RIP works. And that's it about a RIP. Thanks for watching. Until next time.